Okay. Good afternoon, good evening to everyone. So again, we are on YouTube live stream for this other new topic. Uh, Plumbing, sanitary inspection, safety audit or design audit, and green practices. Okay, so now we will proceed immediately because this is also a very long topic. Okay, so let me just tone down my monitor. Okay, and then okay, and that's it. We'll now proceed with the discussion. Okay, so um, we welcome you all, those who are coming to watch this or already online to watch this um, webinar on plumbing. To send us your messages in the chat box. Okay, just um, shout out there so that I can read your names later as we go on with the with the YouTube live. Okay, so now we proceed with the invocation. And the Father, Son, Holy Spirit. Amen. Namang banal na pinupuri ka namin at pinasalamatan sa mga biyaya at sa tuloy-tuloy mong paggabay sa amin. Maraming salamat po sa pagkakataon na makapaglingkod sa aming mga kapatid at sa aming bayan. Sana po ang magawain ito ay magdudulot ng positibong resulta na magbibigay ng dagdag na kalaman, kakayahan at kaunlaran ng bawat isa at para sa aming bayan. At sana po ilayo mo po kami sa sakit at sa mga sakuna. At lahat pong ito ay aming tinataas sa iyo, dakilang Ama, sa pangalan ng iyong anak na si Jesus. Amen. Okay, so I'm Engineer Engineer William Juan. I'm a registered master plumber and I'm also practicing MEPF with an S because we are a solar advocate likewise. And I'm also a professional electrical engineer. So that's a combination of four disciplines in practice. Okay, so I was the former founding president of the Philippine Society of United Master Plumbers, and I was the Pro Change Non-POP National President in 2012. And when the group organized the PISAMP, I was the founding president, and we are also a part of founding director of the MEPF organization of the Philippines. Okay, so I hold the license, registered master plumber number 1970, which I took or was given to me by the Professional Regulations Commission Board of Master Plumber way back in 1989. Okay, so we have already over 30 years of practice in plumbing, and I also finished my BS Mechanical Engineering at the National University as well as my BS Electrical Engineering at the National University. Okay, so here is our table of contents or the topics that we're going to discuss. So we will start with some introduction. Very important here because we will be discussing the status of the plumbing profession, especially the master plumbers practice. And then of course, number 2 will be the safety in LPG piping systems. And number 3 is septic tanks, and then the toxic septic gases. And then of course number 4 is sewer ventilation systems. And number 5 is plumbing works, minimum slope, cleanouts, air gaps, elbow rooms, P-traps, grease traps, and others. And number 6 is water pumping. And number 7 is rainwater harvesting. And number 8 is condensate collection. Number 9 is greywater use. And number 10 is fire protection systems. Okay, uh, part of the backgrounder or introduction, plumbing engineering and sanitary trends in building and homes. Master plumbers or plumbing engineers design or oversee the installation of lower pressure fire protection systems without fire pumps, hot and cold water supply systems and pumping system, Greywater Use, sanitary water lines or sewer lines and sanitary ventilation systems, septic tanks, sump water pumping, AC condensate, drainage, rainwater collection and filtering systems, and stormwater drainage systems, Lpg gas lines, among others. The registered master plumber is mandated by law, Republic Act 1378, to design, check, sign and seal plumbing plans, specifications, plumbing permits, and or supervise the plumbing works of a building or a facility. Okay, here is the preamble, the first part of the Republic Act, which governs the practice of plumbing. The scope of practice prescribed by the Plumbing Law, Republic Act 1378, is as follows. Section 2, letter A. The practice of plumbing within the meaning and intent of this Act shall embrace services in the form of consultations, designing, preparation of plans, specifications, estimates, erection, installation, and supervision of plumbing works, including the inspection and acceptance of materials used therein, the extension and alteration of all pipings to fixtures, appliances, and to appurtenances in connection with any of the following: storm and sanitary drainage, facilities of buildings, the sanitary venting of fixtures, hot and cold water supply systems within or adjacent to any building, storm drains, sewerage system of any premises, and or connection with any public disposal or any acceptable terminal. So, acceptable terminal is the septic tank. The enumeration in this paragraph shall not be construed as excluding any other work requiring plumbing knowledge and application. So, see, the law that governs the practice of plumbing is very powerful in terms of the complete practice of plumbing. It mentions about designing, consultations, preparation of plans, specification, estimates. Okay, it didn't mention sign and seal, but it is very obvious that when you do the designing, you have to sign and seal or certify your design or plans. Okay, now let's see also the preamble of the law that created sanitary engineering. No, so while the scope of practice described by the sanitary engineering law, Republic Act 1364 is letter A, sanitary surveys, reports, design, direction, management, consultation, and investigation of water purification plants, my emphasis water collection and distribution systems, reservoir, drainage and sewer systems, sewage treatment plants, malaria control structures, sewage disposal tanks, and other structures for public health and welfare. Number 2, projects relating to stream pollution, insect and vermin control and eradication, rural and camp sanitation, and milk and food sanitation. Number 3, systems for the prevention of atmospheric pollution or the control of indoor, especially the working spaces in industrial establishments, industrial hygiene engineering. So, letter B, professional research and laboratory work supporting the activities listed in subsection A. So, here. So, let's just go back to here. No? So the practice of the sanitary engineer includes water purification and distribution and drainage and so on. So, but it mentioned here public. So, in other words, so in general, it is intended to provide practice directly for the public. Okay. Now, number 2, it mentions stream pollution. So that means that this is uh, uh, meaning the control of solid waste. No, in other words, you do not like your solid waste to contaminate the rivers or the stream. Okay, so here you have water, like you have the clean water act, and here you have solid, so solid waste management. And number 3 is atmospheric or air. So that means that you don't like your surroundings, environment to be polluted. So air. So they have water, solid waste, and air. Okay. So, but in here, there's no mention of the practice of plumbing inside buildings. Okay. Okay. But why then are they practicing plumbing? Why do sanitary engineers can practice plumbing? Okay. Let me explain. The sanitary engineers can practice plumbing design or can sign and seal plumbing plans, which is the scope of practice of the licensed master plumber. During martial law in 1972 to 1981, there was an obvious improvement in the Philippine economy, and therefore there was construction boom not experienced in prior years since the independence from America in 1946. There was the construction of tall buildings, low-rise to medium to mid-rise, and to up from 5 levels to 17 stories. No, in the Makati CBD area or Central Business Districts, particularly in Ayala and Buendia Avenues, inside the Legazpi Village and the Salcedo Village, and in the Ortigas Central Business Districts, particularly the Strata 100 building, Strata 200, and other buildings there. During these years, there was therefore a need for more master plumbers or plumbing engineers, which the NAMPAP, organized in 1935, cannot provide. The government then, through the initiative of the Ministry of Public Works and the Ministry of Human Settlements, allowed the sanitary engineers to practice plumbing design to address the deficit of plumbing designers engineers. This authorization was done in 1977 through an implementing rule and regulation, or IRR, of the 1972 National Building Code. Therefore, the provision of law that allowed the sanitary engineers to practice plumbing was only an IRR. So it is a law that is less in strength than a Republic Act, which is governed by the master plumber. So in other words, this IRR was only to provide a temporary solution to the lack of master plumbers who can design high-rise or medium-rise or mid-rise buildings during those times. Okay. Of course, since then, since 1986 EDSA, the number of registered master plumbers has increased due to the mismanagement of NAMPAP, the National Master Plumbers Association of the Philippines, the Organization of Master Plumbers. The number of RMP professional organizations has also grown from 1 to 3, from the NAMPAP to 3 to the present. So, NAMPAP was the first in 1935, but like I said, there was some problems in its organizational management, and that brought the organization of PSP, Philippine Society of Plumbing Engineers, in 2004. Since the organization of 2004, there was again no unity between the master plumbers that were in NAMPAP and those that put up the PSP. So from that time, until 2012. Again, there were some uh, misgivings, no, in the NAMPAP, so that therefore a group of pro-change NAMPAP master plumbers uh, decided to separate themselves from the old NAMPAP. Okay, and that happened in 2012. So from 2012 to 2014, this group of pro-change NAMPAP organized the PISAM, the Philippine Society of United Master Plumbers, and had it incorporated in 2013. So from 2012 to 2014, through the initiative of the Board of Master Plumbers, the Philippine Society of United Master Plumbers and the Philippine Society of Plumbing Engineers joined hands for the upgrading of the 1955 Plumbing Act into a proposed plumbing engineering law. So the PRC also and the BMP, together with the BMP, work out for the unification, integration of RMP groups, namely the PSPE 2004, the PISAM 2013, and NAMPAP. The integration was formed after the representatives of the aforementioned RMP groups agreed to unite during the meeting held last December 6, 2016 at the PRC through the initiative of the Honorable PRC Commissioner Yolanda Reyes. Only the Cabase-led NAMPAP opted not to join this umbrella group. During the 16th Congress, the umbrella group worked for the revision of the 1955 Plumbing Act into the proposed plumbing engineering bill, no, which was passed by the technical working group in Congress on first hearing in the House of Representatives, chaired by then the Honorable Carlo Alexis Nograles, present our the Cabinet Secretary. He was then the representative of the 1st District of Davao City. And later, in the Civil Service Committee of the House of Representatives, this is the second hearing, chaired by the Honorable Andres D. Salvacion Jr., the representative of the 3rd District of Leyte. It was finally passed on third reading by the honorable members of the House of Representatives in 2014. However, the Committee on Civil Service in the Senate, chaired by then Senator Antonio Trillanes IV, was not able to pass its version or warrant a bicameral session for its approval and its submission to Malacanang. Until today, the upgrading of RA 1378, the Plumbing Act, is still pending in the Senate and of course in Congress. Okay, in November 2019, after about 15 years of court battle from the Regional Trial Court all the way to the Court of Appeals between the master plumbers and the sanitary engineers, the court has decided to favor the master plumbers. Onward master plumbers zone to become plumbing engineers and certified MEPF engineers. Yes, the Court of Appeals has ruled last year. Master plumbers won the case against sanitary engineers. Master plumber is the authorized profession to design and certify plumbing plans without limitations in regards to the number of floors or fixtures of any building. Congratulations, therefore, to all master plumbers, no? But of course, the congratulations was also hit or given to the Office of the Solicitor General, the Department of Public Works and Highways, the Professional Regulatory Commission, the Board of Master Plumber, and the professional organizations, the PISAM, the PSP, and NAMPAP, for fighting for the plumbing profession. The rights of the master plumbers are now clear and protected through the Plumbing Act, which states in Section 102.2, all plumbing plans, drawings, diagrams, design analysis, computations as required, technical specifications, bill of materials, and other required documents for all types of occupancy shall be prepared, signed, and sealed by a registered and licensed master plumber without limitations pursuant to Republic Act 1378 as amended, and shall be submitted in 6 sets of the aforementioned requirements with each application for a permit. Okay, so that's the end of our backgrounder on the practice of the master plumber. So let's congratulate our fellow master plumbers. Okay, now let's proceed to our main topic, which is the plumbing sanitary inspection, or design works, audit, and inspection. So what would be the samples of sanitary plumbing errors or code violations that you should be mindful of as a plumbing practitioner of when you do your checking, audit, inspection, plumbing designs, and sanitary installations? What are some of the best sanitary plumbing practices? Okay, so let's start with LPG piping system, because LPG piping is critical, because we have seen in the past so many accidents in the improper installation of LPG piping. Okay, let us be reminded that LPG is a flammable gas. It's a mixture of propane and butane, and is liquid under pressure, and it is colorless and odorless in its original or natural state. And the LPG vapor is heavier than air, and therefore the vapor may flow into drains, into canals, into trenches, anything that is low area, meaning to say is not fully open ventilated. But LPG is provided with some sort of a smell, or is odorized by the addition of ethyl mercaptan, so that therefore the tanks, the small tanks like the 11 kilogram tanks and the 50 kilogram tanks, contain this ethyl mercaptan, so that the originally colorless and odorless LPG gas would have this smell, a bad smell, no, odorous smell. Okay, so LPG forms flammable mixture when mixed with air within the flammability limit to large volumes of vapor air mixture. So in other words, it's so dangerous, no? So therefore, my suggestion is that we should check that LPG gas detectors are provided in the LPG piping system, from the LPG tanks to the appliances, no, like for example to the LPG gas burners, or to laundry equipment, no, so laundry dryers, or even in bakeries when they use LPG, no. And of course, in addition to this LPG gas detector, you must also check that there is an installed, or you must provide this electrical solenoid valve. Okay, this electrical solenoid valve will automatically shut off or stop the flow of gas the moment it receives a signal of the presence of leak LPG from your gas detector. This one. Okay, so let me show you where it should be installed. So if you have here a room or a kitchen area, so you have to install the LPG gas detector here, and you must also install the what you call this, the shut-off valve, no, the emergency shut-off valve. Here you have here the ESV, and emergency shut-off valve, or solenoid valve. Okay, so the moment you detect the presence of leak gas, then this solenoid valve should be automatically shut off in order to prevent further leak of this gas. Okay, so that's the number one thing that we have to check. Okay, so if you have a bulk gas tank like this one, oh, let me go back to that. This one shows cylinder tanks of 50 kilos tanks, no? Okay, usually they are as high as almost a meter, or more than a meter, 1 point something like 4 feet in height. Okay, and sometimes they also use these 11 kilogram tanks, which is much smaller. Okay, now if the installation is provided with a bulk gas tank, then most possibly there is no what you call this smell. So you have to require that smell is provided to make sure that the leak gas can also be smelled, detected by people. No, again here you have to install the detector here, and you have to automatically shut off this ESB here, emergency or electrical solenoid valve, so that further leak would be prevented at any point in this area after the emergency solenoid valve. Okay, so let us remind ourselves that there was this explosion in Serendra 2 building, no? Serendra 2 condominium in the Bonifacio Global City in 2013, May 31, where 4 people died. You could see the devastation of the walls of the condominium unit on the 6th floor here. The concrete walls here were shattered by the explosion of the leak gas inside this room, which killed 4 people. Okay, and just to really emphasize the big danger, the big explosion, here on the left side you would see the 6th floor part of the condo unit, where the debris, the walls came from, or the explosion came from, and the debris would reach this van here, this yellow van here, with a circle or an oval. So that's how far the debris from the explosion reached, no? Up to more than a half of this 6-lane roadway, no? There are 3 lanes on one side and 3 lanes on this side, and it reached this point. So you would see the very, very devastating explosion that happened. So that should remind us, therefore, that if we are involved as master plumbers or as MEPF engineers, we should make sure that we are protected with that solenoid valve, and of course the LPG gas detector. Okay, here is a closer picture of the van, and these are the concrete debris which reached the van. 3 people died in here. Of course, they did not die from the gas explosion itself, but it was the debris that hit the car, that killed them. Okay, and even come close to damage this other van here on the right side of the L300 van. Okay, so we have to make sure that your gas detector is permanently connected, not just plugged into an outlet. See, here in the upper picture you would see that the gas detector is plugged in, no? So this is dangerous because somebody might unplug the plug, so the male plug, somebody might unplug it, and therefore it would remove the effectivity of the detector. Okay, so it must be permanently connected. So we have to remind the electrician or the electrical installer to connect permanently the gas detectors, no? The LPG gas detectors. Okay, and the detector must be installed not more than 4 meters away from the appliances, from an appliance that it should protect, and not more than 12 inches or 300 mm from the floor. Because remember, the LPG gas is heavier than air, so it occupies close the space close to the floor. Okay, like I mentioned earlier, these are the characteristics of the LPG gas. Here are pictures showing that the LPG tank should be installed outside in well-ventilated areas, as you see here in this picture on the right side. And the picture on the left side, you would see an opening on the parapet wall of a building. So these tanks, how many tanks? 1, 2, 3, 4, 6 times 2, 12 tanks are installed at the roof deck of a certain building in Makati, and there is an opening in the parapet wall here to allow any gas that might have leaked. If there is gas that might leak from these tanks, the gas would be diluted by air that would come inside this opening here and on the right side of this left picture. Okay, so that should be the way it should be installed. We should never mount an LPG tank on top of unstable mounting. No, we should install it on a more permanent mounting. Of course, this one, it provided for a chain, but again, the mounting is plastic, so it's not stable. So we have to make it more stable. Okay. And here you would see an installation at the back of a house. In electrical installation, we should not allow any convenience outlet or switch or breaker or anything that would initiate a spark within 5 to 10 feet of the tanks. Okay, so not allowed to install an outlet, a switch, a breaker, or any other possible source of arc or spark or ignition. Okay? According to the NFPA 58 and NFPA 30A, established electrical area classification for outdoor stationary LPG or propane fueling stations, pressure relief points, above ground storage, etc. Within 5 feet radius from the LPG tank's nozzle is considered hazardous area. So we should not provide this kind of devices, no? Outlets or breakers or switches, okay? Or any load for that matter, like for example, installing an electric fan or a motor or what, within 5 to 10 feet of that source of LPG fuel is dangerous. It's not allowed by the Philippine Electrical Code and also the National Electrical Code. Okay, so LPG vessels is stored at consumers' premises. Is a pressurized LPG vessel or tallest, and which can be manifolded or piped together. The design pressure of the vessel or cylinder is usually 250 pounds per square inch or PSI. Bulk LPG storage vessels or bullets may be installed in any of the following configurations: above ground, underground, or mounted. So above ground meaning to say is just mounted above ground, and underground is just below ground, and mounted meaning to say is above ground but is provided with earth to cover it. Okay, here is a mounted installation. So we have an LPG tank installed on the ground, but an earth is provided to cover it up, okay, to make it secured in case there is LPG leak. Of course, on this side there is no covering, but there is a provision of a firewall here and a retaining wall, so that in case there would be leak here, it would not just contaminate the bigger part of the tank. Okay, and usually LPG spray facilities are provided to protect against fire that might happen in the nozzle of the tanks. So you would see piping here, water piping, color red, which would spray water in case there is an LPG leak fire. And you see there is also a retaining wall here to retain any LPG leak that might come out of a leak. Okay. Now here's an installation where the solenoid valve, the electric solenoid valve that I mentioned, is here on the upper portion of this piping here. Ito, this portion, solenoid valve here. Of course, there are some valves here like these manual valves, ball valves. Here is a ball valve here below the pressure regulator, and there is a ball valve here before the gas meter strainer, and after the gas meter there is another one again. But all of these can only be operated manually, while this electrical solenoid valve can operate remotely, can operate automatically. Okay, so now let's continue on. Service pipeline is used for delivering the LPG vapor from the storage tank to the gas appliances. Pressure regulators are installed along the line to reduce the vapor pressure progressively from the tank operating pressure of about 60 to 100 psi to the appliance operating pressure of 300 mm water column or 0.5 psig. Okay, so this pressure reduction is normally carried out in 2 stages for better reliability and safety, such that the gas line pressure in the building is reduced to not more than 35 kilopascal or 5 psig. So from 60 to 100 psi, you reduce it to 5 psig until you reduce further to 0.5 psig. The schematic diagrams earlier shown typical configuration of piping installed for both bulk gas and in cylinders. Pressure losses in piping system would be from 0.2 to 0.5 inch, 5 to 12.7 mm water column, approximately 0.3 inch, 7.6 mm water column as commonly used number. Here is an installation of the gas where the hose are very long, extraordinarily long. We should not allow these hoses to be used because they are so long. There's a greater chance of leak in such kind of very long hoses. Let me just compare this to the previous slide. Here you would see the hoses here much shorter, much shorter from the tank to the gate valve. Okay, as compared to this one, which is very long. Okay, so this is not good. Okay, here the tanks are should be properly secured. So you would see here there is a chain here for the two, but in this other two, we do not see a chain. So there's a possibility that if you have a strong tremor, they could be unstable. Also, there is no guardrails in front of the tanks, especially if the front portion is a parking area. Okay, and here you would see a compartment provided. So they provide an opening on the lower portion to allow the movement of leak gas in case. But the owners allowed storage of unnecessary materials on top of the tank storage. So it's not good. Plus, you would see down below a trench with a grating, no? So this is also a violation or dangerous, no? The presence of this trench below. If there is a leak gas, the leak gas could just stay in the trench waiting for a spark in the area. So should not allow this. And we should also not allow a dirty surrounding for LPG tank. So here we have this white bullet tank here, and then you would see clutters around. You would see plants and garbage. So it's not a good way to maintain your LPG bullet tanks. This one is another one that is not also good, where you would see a mound here on the left side, and there are grass in the area. So it is not also good, because if there would be a leak gas, the leak gas would just stay in the grasses waiting for a spark or a cigarette butt with a light in it. So it's not good. Now, this installation, say for example this is LPG, is also unsafe because there is no guard that protects this bullet tank. In front of here, maybe in the line of the shadow, should be installed bollards or posts to prevent vehicles to come close to the tank. You may not know if a vehicle that come to park in this area would lose its brake, no? I mean, the driver would lose its brake and would bump this LPG tank. So, and here, this is a correct way of installing it. As you would see, this LPG bullet tank being provided by these guardrails here, these yellow guardrails, and also the flooring is finished flat. No manholes, no canals, or no what else? Where possible LPG leak would go down. So it's dangerous. Okay. So this one is another one with the bollards. Like I said, so it's in a parking area, so they provide the bollards to prevent any car that might come close to it, okay, from being bumped. Okay, pressure regulator should also be provided. So this is the pressure regulator. This red one, and this is the gas meter. The gray colored portion is the gas meter. And vaporizer should also be installed here. But vaporizer should be installed outside of the building, never inside the buildings. The vaporizers converts the LPG gas into gaseous state, because when it is compressed, it is in a liquid state. Okay. Wall-mounted vaporizer shall be at least 1.8 meters above the ground. Okay. Shall not be installed inside steel cabinet within the same housing as the LPG cylinders. So must be separate. Okay, so not to be installed inside, not to be mounted together in the LPG cabinet, and wall mounted and at least 1.8 meters high. Here is another vaporizer installed, and here is a knockout pot. A knockout pot is a one that would filter off residues or collect heavy ends or residues, impurities of the LPG gas. No, at least 2 drain valves. Drain shall end to the ground level and plug at the end. Okay, drain valve open position valve, and then of course drain valve close position valve. So once in a while, this should be regularly open to allow the expulsion of this residue inside the LPG piping system. Of course, why do we do this? Because we do not want the residues, the dirt, to go to the burners, which would affect the performance of your burners. Here is an installation that would include almost all of the systems. You would see here, of course, the LPG tanks, the blue pipeline, yellow pipeline. Then there is the auto change over valve. There's a regulator. There is the vaporizer, and then another regulator here. The overpressure protection device. Knockout pot here. This one, this yellow one. And there is an emergency shut off valve here, but it is only not, it is not a solenoid operated, not electrically operated. So this is the one lacking here. When we check on this installation, we should check where the emergency shut off valve, meaning the electrical solenoid valve is. Not only this manual shut off valve. We should have an automatic shut off valve, okay, an electronic shut off valve, electrical shut off valve. Okay, so not only the manual valve, but also an electronic or electrical shut off valve. Okay, when piping is done to interior of the building, there should be a sleeve pipe that should be provided for the LPG gas line. The blue line is the LPG gas line, and the black lines indicates the pipe, the shield pipe. And there is a provision of a vent at the outside of the building to allow for any leak gas that would come out. Here is some photos for how the this shield or pipe, gas pipe, gas sleeve should be installed when inside the building. Okay, so you would see here the pipe, the dark black line is the gas line, and the outside white line as the, or gray line as the sleeve pipe. Okay, here is an actual picture. You would see the yellow pipe there inside this sleeve pipe, the translucent sleeve pipe. Okay, here's another picture of the installation. Of course, there is a provided here. You have to provide here the gas detector to make sure that if there is a leak gas, it should alarm and automatically would shut off the electrical solenoid valve. Okay, so here I'm just showing you an LPG tank room where louvers were provided, but when yours truly were asked to do the inspection, I have to ask the contractor to add more ventilating louvers on another side of the room to provide adequate cross ventilation of the room. Okay, and here I also asked the contractor to provide ventilation in the kitchen. This is the kitchen door of the one that I inspected in the PESA zone in Batangas, in Tanawan, which I asked them to provide additional ventilating room as a safety measure. Okay, and here we should not allow the provision of this trench or canal inside the kitchen. Here you would see the plastic covered gas burners, and these canals are not should be rejected, should not be allowed to be provided here, because it will accumulate any leak gas and would would cause an explosion if when there is a spark or a flame. In other words, when when your detector did not function, you cannot just rely on the detector that it will always be functioning. At times it can also malfunction, no? Okay, so here is an installation of a agent type suppression system using FM200. So the yellow, the orange pipelines indicate the agent suppression, and the blue lines show the line of the detector lines, the fire detector lines, like say fire detector, heat detector, and so on. And here another installation in a kitchen for this suppression system for a type B. And here another one where the suppression system is provided, including the necessary piping here. So that's it. So we just show you how to provide protection for your LPG installation. Let's have a short break in the meantime. Okay, so we've been able to consume something like almost 1 hour. Okay, so we are back. Let's resume. So now we are on item 3, septic tanks and toxic septic gases from the septic tank. Okay, so let's start with methane and hydrogen sulfide. This slide shows us the devastating explosion that happened in Glorieta 2 in Ayala in Makati sometime in 2007, no? October 19, 2007, Glorieta 2 in Makati, with 11 people died in this incident. So you would see a picture of the basement. So when the explosion happened, the so many items here or structures were shattered because of the intensity or the strength of the explosion. Okay, it is so dangerous because what happened in this is that there was a leak gas or accumulated gas in the basement, in the sump. So they have usually a sump would have the sump pumps, no? Usually we have two sump pumps. One is the running pump and the standby pump. But presumably, the sump pumps were not adequately maintained by the maintenance personnel of the building, and methane gas accumulated there at the sump. And later on, of course, when the gas was too many, and there was maybe an unplugging of a charger of a phone, or maybe switching of a light switch, which causes spark, or anything else that would have caused the spark. At an instant, this gas, methane, which is highly flammable, including hydrogen sulfide, exploded. These gases are usually are heavier than air, no? Heavier than air, and therefore they would occupy the space closer to the ground or to the floor, and therefore people would not just be able to easily notice it or smell it unless the area is open ventilated. When it is open ventilated, then the bad smell of the hydrogen sulfide could be smelled, no? But if it is an air conditioned area, usually this methane gas and the hydrogen sulfide would just be there, waiting for a spark or an arc to ignite it. And that's what happened in this Glorieta explosion. So we should to be very careful. Okay, so my suggestion is that if you are the designer or consultant for plumbing sanitary of such a facility having a basement, we should strongly suggest to the architect or to the owner not to provide a toilet or a restroom in the basement, because when you provide this restroom there, you will always need a sump pump to collect the sewage, the sewer water, the dirty water. And by collecting it, you will be needing sump pumps. And Marpilo says that even if you have the sump pumps, then if something go wrong, no? Meaning to say, like in the case of the Glorieta, they were not properly maintained. So it happened, and it caused this explosion that killed 11 people. Okay, so it's better to provide the restroom or the toilets on the ground floor or second or third floors or fourth floor of a mall, so that when you flush the toilets, the dirty water, the sewage would just simply flow outside or flow in the lines that has slope, and will just empty going to the septic tank or to the collecting tank of the sewage, or to the STP system. Okay? Now we proceed to wrong designs of septic tanks. Okay. Here is a number one wrong design error number one. Okay. Carefully look at the septic tank here, the design of the septic tank. You would notice that there are two chambers. So here is the digestive chamber, and here is the leaching chamber. Okay. Actually, many master plumbers still call the second tank as leaching chamber, when in fact it should be called settling tank, not leaching tank. Okay. Now you would notice here that the contractor or the designer use elbow here, elbow for the incoming nozzle, and another elbow for the one that would transfer from the digestive to the settling or to the second chamber, and another elbow to the outside. No? Let's just assume that this design could be three chamber type, meaning to say this second tank could be divided into two. So this is a wrong design, because elbows are not good to use. No? they might be cheaper than the sanitary tea, but it is not the correct way to provide the piping or the nozzles inside the septic tank. Okay, so my comment here is the inadvertent lack of cross ventilation of the septic tank due to the use of sanitary elbows instead of sanitary teas stops the biological process in the digestive chamber. So these elbows will not allow the free movement of fresh air or oxygen to the digestive chamber, and thereby slows down or even kill the bacteria inside the digestive chamber. Okay. Design error number 2. This one is almost similar to the to the earlier slide. It makes use of the T, but again the T is directly going to the top of the tanks. No, as you would see, this T continues to the tank, and therefore again it disallows the movement of the air that I was mentioning earlier. I will show you later a drawing which shows you how the air or how oxygen can be supplied to the digestive or to the tanks inside the septic tanks. So this is design error number 2. Same comments, no, that T are incorrect. These T sanitary T's are incorrect. Okay. So then there's a need for cross ventilation of the tanks. In the use of the septic tanks, the drain of its effluent to the storm drainage system in some communities where STPs are not provided, the attached sketch shows the movement of the air from the street drainage pipe to the vent through roof. Okay, so let me show you this to make it clearer. Here. So, how would the air move? So here I prepare a simple design of a house with the piping, sanitary piping, the ventilation. Here you have here the water closet and the lavatory. Of course, the water closet has its own trap seal, and the lavatory has its own trap seal. And I just overemphasize the ventilation going to the roof here, the vent through roof. Okay, and the sloping sewer pipe going to the digestive chamber. Of course, the digestive chamber could be 3 chambers. So this digestive and the settling tanks could be divided into 2. So that will make it into 3 chambers. Now, how would the air move? I have shown here in arrows the movement of the air, as you would see. When the storm drainage pipe is not full of water, meaning to say it's not there is no strong rain, then normally the air would flow here, would come in here, and would go here as the arrow indicates, gets inside here, and it would flow there out to the vent through roof. How will it move? Okay, by the nature of the natural ventilation caused by the heat of the sun. When the sun comes out in the morning until the afternoon, the sun would hit the surroundings, would hit also the vent pipe. So the vent pipe, when heated, the hot air in the upper portion of the vent through roof will come out of the VTR, of the vent through roof. It will come out there, sucking out the air inside the system. So therefore, air would come here, would come inside here, would come to the digestive chamber, and then would go and come out of the VTR by nature of that natural ventilation of hot air in the upper part of the VTR. Okay, this is a phenomenon that was not explained in any plumbing books, and uh, of course, the book by Max Fajardo indicates the use of T, no? T, not elbows, or T that is cut and not direct to the clean out at the top of the tanks, no? This T or this T nozzle, baffle, have a clean out at the top of the tank, but there would be an air gap between the upper portion of the T and the bottom of the septic tank. So this air gap will allow the movement of this air until it flows there. Of course, this process during daytime is interrupted by the use of the water closet. When somebody uses the water closet, then the person would flush the toilets. At that point in time, water would be flowing through the pipe, and therefore the flow of this air would temporarily stop, okay, until the dirty water would reach the digestive chamber. Then the extra water would flow to the next chambers, and then the extra again will flow away to the storm drainage outside, combined storm drainage. After that, when the water already has normalized, then again the air would move to the vent row, slowly but surely. Now, this process do not happen at night time because there is no heating of the upper portion of the vent row. This only happens during daytime, and therefore such kind of a system where you use T, like in this sketch, will not allow cross ventilation. So with this use of elbows will not also allow cross ventilation to happen, and therefore this system will create a very bad process. So the surroundings will be very bad smelling. So there will be an odor that would be coming out from the sewage water or effluent coming from the septic tanks. Okay, so with this, okay, so that should make clear of the purpose of the cross ventilation, which is a phenomenon not included in plumbing books. Okay, so again, I have here explanation of that. So in one project that we inspected in Leyte, so we have to explain to the site engineer, to the site plumbing sanitary engineer, the need for this cross ventilation. Okay. Now there is design error number 3 is many master plumbers that I've seen still use this leaching well or leaching chamber. This is no longer allowed by the Clean Water Act. So it has been already replaced by the 3-chamber design, and there is no more this hole or leaching well on the second or the third chamber. Okay, as per the Clean Water Act of 2004, RA 9275, the sewage water in the leaching well in this design may contaminate the underground water table or the water aquifer. Therefore, it is no longer allowed. Due to this, the settling chamber must now be consist of 2 sections to allow for longer settling period to produce cleaner effluent. So this is the reason why this is no longer allowed by law. So it is a violation of the Clean Water Act. It is a sorry state that the revised National Plumbing Code was last edited in 1999, and the Clean Water Act came out in 2004. So the revised National Plumbing Code has not been updated to include this provision of law. Okay, so I would like to ask my fellow master plumbers in the Philippine Society of United Master Plumbers to immediately form a group to revise provisions in the National Plumbing Code that would go against this provision of the Clean Water Act. Okay, to go to the Clean Water Act. What is the Clean Water Act? The Philippine Clean Water Act of 2004, Republic Act 9275, aims to protect the country's water bodies from pollution from land-based sources like industries and commercial establishments, agriculture, community, and household activities. So when you say household, that means the septic tank. No, it provides for a comprehensive and integrated strategy to prevent and minimize pollution through a multi-sectoral and participatory approach involving all stakeholders. Okay, how will the discharge of the wastewater be discouraged? Anyone discharging wastewater into a water body has to pay a wastewater charge. Okay, but this provision of the law has been abused by many industrial manufacturing facilities, no, or companies that discharge dirty water. They would not provide sewage treatment plants, and therefore they would just pay for the penalties, and that resulted in the dirty water in the dirty sewer or sewage in Boracay and also in the Manila Bay. What are the prohibited acts in the 1975? Among others, the act prohibits the following: discharging or depositing of any water pollutant to the water body or such which will impede natural flow in the water body. Discharging, injecting, or allowing the enter into the soil anything that would pollute groundwater. So in this, it didn't say that the septic tank, no, but the old design of septic tank with a leaching chamber, it did mention, but it is very obvious that that kind of design violates this provision of the Clean Water Act. Additional, operating facilities that discharge regulated water pollutants without the valid required permits, disposal of potentially infectious medical waste into the sea by vessels. No? Addition, no? Among others, unauthorized transport and dumping into the waters of sewage, sludge, and solid waste. So in other words, when you remove or suck the sewage inside septic tanks and just dump it in the bodies of water elsewhere and might contaminate the water, is also prohibited by this Clean Water Act. Transport, dumping, discharge prohibited chemicals is also disallowed by the Clean Water Act. Discharging regulated water pollutants without the valid required discharge permit pursuant to this act. Non-compliance of LGUs with the Water Quality Framework and Maintenance Management Area Action Plan. Okay. Additionals, no? Let me just emphasize the one in red. Directly using booster pumps in the distribution system or tampering with the water supply in such a way to alter or impair the water quality. So, see, even the use of booster pump to suck or to boost or suck the water from the water line, is also prohibited, specifically prohibited in the Clean Water Act. Okay. Now we proceed with some other designs. I was able to research from the internet a design of the American in the US of a septic tank shown like this. But you will notice that on the second chamber there is no more the leaching chamber, but you would notice a cover in the T here. There is a cover in the T, and therefore this T would not, or covered T would disallow the movement of the oxygen or the air, as I mentioned earlier in the cross ventilation scheme. Okay, so this one should not be there, this cover here. This one on the middle is okay, and this one on the first chamber, the entry point nozzle, is also okay. This one okay, but this one is not Okay. So in other words, even the Americans are confused in the correct way of providing this design of the septic tank. But there is also this book designed by Elwin Zilai, which would show a ventilation. No, I was trying to compare. No, you would see here uh, three chamber. No, this is the first chamber, a digestive chamber, and this is the settling chamber, and it uses T. This one T, and this one is also a T. But here it uses a venturi, no? And you would see here a vent that would allow the movement of air here, there, and at the end it would exit to the vent through rope. So this one is a correct design. It's also a correct design. This one, let's check, is also a correct design. We just picked this up from the internet, from Facebook, I think. You would see that there is a movement of air here because there is a gap here between the cover of the septic tank and the top of the vent of the T. So here it moves that way, then again enters here, then exits here, then enters here, there, and goes to the vent through rope. So this one interpreted by Ralston John Basig, also a registered master plumber, is a correct design. Okay, he provided here manholes of adequate sizes. Here, manholes. Of course, they're no longer the clean out provided because there is already the manhole, and there is no more the leaching chambers. Okay. But of course, this design simply show two chamber. It must already be three chamber design. Okay, so this right side chamber should already be divided into two, or should be duplicated for another one, so that it would become much cleaner. So that's the only problem with this design. There is cross ventilation, but the number of chamber should be 3. Okay, here, about this one. This kind of design will also allow the movement of the air because it uses T. Okay, let's analyze. Here, from the effluent, so the air would go there, come out there, then come in here, go out again, and here, there, and there. So there is that air space above the baffles or the nozzles, no? So that would allow the movement of air. So this is also a correct design. And there are no leaching wells or leaching chambers. So it's a correct design also. Okay? And this one is also a correct design. Except that there is a vent. It shows a very small vent, low vent. And the problem is it might be very close to the nose of people around. So the vent should be long enough away from people walking, so to make sure that the obnoxious odor would not come close to people. Okay, that's the only problem with this sketch. These vents should be long enough to go to the atmosphere, to empty to the atmosphere. At least, in my own opinion, should be as high as 8 feet from the ground. Okay, 8 feet from the ground. Okay, so it allows cross ventilation because of the presence of this vent as well as the use of T. And there is also this cross pipe here that would allow the movement of the air going to the vent through roof. Okay, so this is correct. And this one is also correct because it uses a T, and there is also the air gap here in the upper portion here, air gap there. So this is a correct design of the anaerobic baffled septic tank. This one, yes, it is also correct. Of course, it didn't show, just simply show the arrow, but this arrow at the upper portion of the tanks show the possible movement of air ventilation there. The air would move there until it would go to the vent through roof. Of course, it provides for how many settling chambers? 1, 2, 3, 4, 5, and 6. So there are 6 settling chambers after the digestive chamber. So I would believe that this is also a very efficient design. Okay, but I would suggest my fellow plumbing practitioners to use another design. Okay, this is an easy way. This slide show you an easy way to determine your tank size. Okay, if you're the number of people is let's say 11 to 15 people in a house, so the inside width of the tank would be, of the septic tank would be 1.75 meters, and the inside length would be 2.7 meters. The depth of the liquid would be 1.2 meters, and the inside height of the tank, inside height, is 1.5 meters. Now, if you are using it for commercial, say you have 100 people, up to 100 people, then 3 meters is the inside width, 3.6 is the inside length, and 1.5 meters is the depth of the liquid, and 2 meters is the depth of the tank. So this is a shortcut way of designing your 3-chamber design. Okay, here I provided here a tank design that already has 2 leaching chambers or settling chambers. No, digestion chamber 1, leaching or settling chamber 1, and leaching or settling chamber 2. But here, of course, the nozzles are the nozzle uses T's here with air gaps. Okay, and you would notice that on the last portion is a sand filter. So the sand filter is divided into 2. The first this first part is a gravel field, and the last portion would be with a sand filter, and therefore this would allow a cleaner effluent. The sand filter would trap the dirty water. Okay, so that should be the way the sand filter is being designed, or our septic tank should be designed so that our effluents will be much cleaner. We do not rely anymore on the 3-chamber design. We should add this sand filter. Okay, and then here I prepared another simple design where again it is a wider design with a shorter length. You will see here the digestive chamber, and then settling, and then the sand filter. So you would have a cleaner effluent. Okay, you would notice that we did the part of the settling tank or the sand filter shallower than the depth of the septic tank, so that it would be easier to replace the gravel or the sand filter in case you're going to maintain them. Okay, so that's our suggestion to have, so 2 designs with sand filter. This one a longitudinal one, and this one a rectangular one. Okay, so we have provided an alternative design to make sure that our effluents are much cleaner than the present design provided for by the Clean Water Act. You know, the revised National Plumbing Code provided for that leaching well, and the Clean Water Act this allows the leaching well, and our suggestion today with this already provides for a cleaner effluent. Of course, this kind of design is also good with 6 settling chambers. So much better than the 3-chamber design. Okay? So let's proceed with the new sewer ventilation systems. And this is the AAVs. These automatic or air admittance valves, or AAVs, no, are already being suggested for usage. These AAVs were invented by I think from Austria in Europe. It is used to provide as an alternative way of venting. But the problem with this air admittance valve is that it is a mechanical device, no? A mechanical, just like a check valve, a one-way flow air valve. When you use this in installation, let me explain it to you, no? Like this one, no? Here is the vent. Usually this should go to the vent through row, but the installer provide for the air admittance valve here. So here, when you flush your toilets, air would come in here, there, to inside your sewer system, no, to your ventilation system, and therefore preventing the siphoning of your trap seal here in the P trap. Okay, but the problem, like I said, is that this is a mechanical thing, no. You may not know if something would get inside it or damage the check valve, no, eventually, and eventually, let's say, for example, ants would get inside, or some insects would get inside it and would stop the movement of the valve. And if that happens, a not so tight closing of the admittance valve will therefore create a leak of toxic gas or obnoxious gas to your bathroom. And if you have a studio type room where you have a toilet in your studio unit, then there's a possibility that you will be poisoning the person living in that unit. Okay, so that's the problem. Here is a drawing of that mechanical device, no. So when you flush the toilets, this device, which has a spring, so it has a spring, so there will be a vacuum that would be created there when you flush the toilets. The vacuum will then allow the entry of air here to inside your sanitary system, as shown by these arrows, no. But look, when this opens, and if dirt would come into this point here, dirt or ants or other insects would come in, we'll never know, no, in the year of the system, let's say 10 years, 15 years, 25 years. So eventually, when something comes in between this check valve here, the tightness of the closing will no longer be the same, just like when it is brand new. At that point in time, obnoxious odor will now come inside your bathroom. So that's the big danger of this, no. It could be good in the start, but eventually might cause a problem. In the vent through roof, since it is always open to the atmosphere, then this obnoxious odor will always flow there. And also this admittance valve, when used all together in a house or in a building, will prevent the the cross ventilation that I was explaining earlier in the septic tanks. Okay. So my suggestion is this should only be used sparingly. Okay. It should only be used, say, in extensions where it is difficult to install the continuation of the vent through roof to connect the vent of your lavatory to the vent through roof. Okay, like in this, no, you see here the vent through roof. The vent here. So usually the vent through roof is in here, going up. So the AAV is here. Okay, so that's my main objection on the admittance valve. Should not be totally used in all, especially in big buildings. The main vent should still be a VTR, while in rooms it should be, we should reduce the usage of this. Okay. In two-line sewer ventilation system. Okay, so here you would see here improper installation of vents. No, here on the left side here there is no vent, so it's wrong installation. On the right side is the correct one. No, here is also wrong because the vent is horizontal. No, so when you flush your toilets, you could flood your vent. No, so there's a problem. It will not function well. On the right side is a correct way of installing the vent at a certain angle, at a 45 degrees angle. And here again is not also correct. The correct one is here on the right side. Okay. Here there is a vent inside the ceiling. This one, vent inside the ceiling. So there's a problem with this. The obnoxious odor could come out here inside your home and could contaminate the people inside the house. Okay, so it's dangerous. It would be much better to extend this vent to outside of the house to make sure that the obnoxious odor would come back. Or otherwise, if the inside of the ceiling is well ventilated, then maybe could also be possible. But as much as possible, we should not use this kind of venting inside the roof. And of course, here you would see the length of the required length of the vent here. Okay, there should be a minimum length of the vents, no, but from windows it must be at a certain distance, no. Okay, here is another installation that do not provide for a vent through roof. Okay, and here it make use of we call it a loop vent. So your vent here is connected to a vent there. Okay, you have to make sure that this loop vent would be, notice that when water is up to here, the water could and there is a blockage here, it could probably reach this point of the vent and contaminate your vent. So you have to be very careful with this kind of a loop vent. Okay, so here is an installation. The vent here, notice that the vertical vent is at almost horizontal, this one. So it's incorrect. It should be at an angle going up. So that's the correct way to install the vent. Okay. And here you would notice again that here where the arrow is, shows that the vent here is horizontal. It should be at an angle up to 45 degrees. Okay. Again here, you would also notice the installation here. Okay. Anything that goes to the vent should be at 45 degrees so that it would allow, it would not reduce, or it would, when there is problem on the plumbing system, the vent will not be subjected to what you call this difficulty in allowing the movement of the ventilating of the ventilating air. Again here, you would notice that this pipe goes to the vent. No, so again here it should be at 45 degrees going up. So that means that the installation of this pipe should be made lower. Okay. And so with this, you would notice, but here you would notice that it would go up at 45 degrees, and this one is going up, so it must be correct. Okay. Here you would notice the vent here at the last portion is the vent. It should be tilted going up, not horizontal. This last portion here near the clean out. Okay. Okay, how about here? Of course, very difficult to see because they are at a different angle, but usually in actual inspection you would be able to see the angle at which the vent would be coming out from the horizontal line, from the sanitary line or sewer line. Okay, and there is also a solvent ventilation system. They call it the solvent ventilation system, and here it is. Here is the design of the solvent ventilation system. It uses single. The previous venting it uses two pipes, one for the sewer, and the other one is for the ventilation. In here, the ventilation is being used by the same pipe. Okay, and here is a design, a comparison between the conventional two pipe system and the Solvent system. So here is the Solvent system. So it's a little different actually. So usually most practitioners, especially in the Philippines, make use of the two pipe system. Okay, but the Solvent system, Solvent type, named after his inventor, is also possible, no? And it saves, it less cost in terms of piping. Okay, and here is another schematic showing the solvent piping. You would notice this fixture here and this one here, and the vent is here. The vent is the same pipe. Is the same soil pipe or stock. Okay, and this is the aerator, the aeration function, no? So it's a little different from what we are used to do to use, the two piping system. Okay, so this further explains the solvent solvent system. And here, and here, so a single stack pipe. Okay, so it's quite different from the present system. Again, this one, so it seems like there is a loop here, no? So as it moves here, then air would move here to allow for circulation of the pipe. Okay, so that's how the solvent system is illustrated. Is another graphic showing it. Okay, so this is the solvent aerator. So when there is dirty water here flowing, the air would move here to allow for the movement. Okay. Mechanics of the solvent system: a large amount of waste and sewage discharges from the fixtures could form like a slug that presses the air downwards the pipe and create two kinds of forces such as pressure and suctions. The downward force called plus pressure create backflow of water seal in the P-trap and lower fixtures, while the suction force called minus pressure creates siphonage inside the pipe, pulling down the water seal of the fixtures in the upper floor. So anyway, so that's how it is, how it works. Okay. Okay, and here it's also provided here also some more details for your reference. Now we proceed to some others, no? So there's the minimum sizes for slope, tees, and so on and so forth. Elbows, traps, grease traps, other plumbing devices. So here is the standards for drain waste pipe size example. So here we just added here some details for easy reference. Okay, so like here you have let's say a tub, lavatories, toilet, and so on and so forth. So okay, so this could be a guide to determine the drain and fixture units. Okay, and sizing for drain pipes is here for easy reference. Here again, and here again. So I just added here for your reference. And proper placement of the tees in horizontal drain line. So here are graphics showing what is correct and what is wrong. So on the left side is a wrong way of using this. There is a T and an elbow being used here, so it's not correct. So what should be the correct way is the use of the sanitary T, like this one. Here is a wrong way of using the sanitary T, and there is a vertical drop. And the correct way is to use similar to this, an elbow, a 45-degree elbow, and or 1/8 elbow, and a Y. Okay, so that's the correct way. Here also showing the correct way. This upper drawing, and this one too, and the lower portion is the incorrect way. Now we go to the minimum slope. The minimum slope is 2%. Okay, except that of course in some installation, like in some reworks, maybe lesser than 2% is allowed. Of course, in larger pipes, you could be allowed to use a bigger slope. Too big a slope will prevent or stack up the dirt, the solids. The correct is 2%. Cleanouts. Cleanout should be provided as much as possible. Oh, by the way, this is an explanation of that too steep. It might not carry the dirt inside the pipe. So in the middle is the correct way. Okay. Cleanouts must be adequately provided, like this one. And also here. So according to the code, cleanout should be provided every time there is a change in the direction of the piping of the plumbing. Okay, so every time there is a change in direction, cleanouts must be provided. So in here, clean out, and so on and so forth. You would notice that there are inadequate cleanouts. Here, like in here, again, elbows are used for, should be 45-degree elbows, not the 90-degree elbows. Here, clean out should be provided, should be accessible. Okay, so should not be provided where it is difficult to access it for maintenance purposes. Air gaps. We should notice that this kind of valves, sometimes very today most of the valves, gate valves that we use are already the long sweep valves, something like this, that way. Elbow rooms. Now there should be adequate elbow rooms provided for proper maintenance of bathrooms or toilets. Grease traps. Grease traps must be provided. Oh, let me check. This is still the correct way of installing the P-trap. Okay. The grease trap should be provided in kitchens. No. So here you have the kitchen sink, but underneath is no grease trap. Okay. So here there is a trap, but there is no grease trap again. A grease trap is one that would separate the oil or the grease from the water. Because oil is lighter than water, it would float here, and the water would just flow there. Of course, if it's not properly maintained, there will come a time when the oil would be, or this chamber in the middle would be full of oil, which had become a grease, and it might already be up to this point, and therefore it would clog your grease trap, and therefore you have to clean it. You have to open the cover and remove the grease that has solidified. Okay, the grease trap should be installed as close as possible to the fixture, to the kitchen lavatory or kitchen sink. More than one fixture can discharge into the same trap, provided that the trap has sufficient pipe size and the waste pipe is not very long. Earth-cold grease trap is used on a large installation, is most desirable type. Deviation width should be not less than 60 mm long. Okay, and here is an example of a grease trap installed using a stainless metal, stainless steel metal. Other plumbing errors. You would see here a water line which is not provided with the correct backfill. When installing water lines, the backfill that we use, the soil that we should use, should be sand, not just ordinary soil. Okay, It should be sand, because the sand would provide additional filtering in case there would be leak in the water line. Okay? So sand should be used as a backfill. Plumbing materials. Okay. Piping should be grounded. So this is the work of the electrical, but as plumbing professionals, plumbing practitioners, we should we should check for safety of the installation. So if you use GI pipe, they should be grounded. If you use copper pipe, they should be grounded. If you use stainless steel pipes for your plumbing, you should be grounded to earth, so that in case there is a voltage or potential that is induced by, let's say, lightning or some other sources of over voltage, your metallic pipe would have a voltage equal to the voltage of the ground, which is 0. Okay, here you would see an equal diameter of the pipe, no? Here. Okay. You would notice here that there is a water line here, but it is very close to the sewer line. We should install the water line far enough or far away enough from the sewer line. Here is another installation. You will see the blue water pipe just sitting on top of the sanitary pipe. So this should not be allowed. Okay. Here you would notice there is the septic tank being constructed, but the elbow here is a 90-degree elbow. They should make use of a 45-degree elbow and should be provided also with a clean out at the portion of change of direction. Like here, no? This arrow, upper portion of the arrow, shows the better way to install the plumbing line or sanitary line. Here you would notice, okay, this is a vent. Let us check. This comes from the fixture. There is a vent. This is a vent. Correct way of venting. Okay. How about the clean out? I do not say clean out here. There should be a clean out. Here. There's a clean out here. Okay. Okay, so air gap here, this lower portion, improper plug. So here you would note this arrow here below. You would notice that just the contractor just simply use a fabricated PVC plug. Should use a correct plug. Water pumping. Okay, water pumping. Total discharge, total head. The capacity of the pump should be adequate to be able to create the pressure. Okay. Here is a booster pump installed directly sucking the water from the main line. This should not be allowed. This is against the Clean Water Act. There should be a storage tank or a cistern tank to store the water, and you can only use water to pump water from the storage tank. Okay. If the pressure of the water is strong, then you can use this bypass line below. Okay. And there is the new system of pumping. We call it the constant pressure system or upfeed system, which make use of the very efficient willow inverter pumps or willow inverter technology or using variable frequency drive. The conventional system is you have a pump to transfer water from your cistern to the topmost floor, and from the topmost floor, water would be distributed to the different floors using the down feed pipe. So you have, in this system, the conventional system, you have an up feed pipe and you would have a down feed pipe. So here you have the elevated water tank. In the constant pressure system, you do not need an elevated water tank, just like in this picture. Okay, this picture uses a bladder tank. This white tank is a bladder tank, and of course, the secret of this efficient operation is this controller on the left side, variable frequency controller. Okay, here's another one, a single motor constant pressure system, and it has its own bladder tank. So with here, 3 pumps here, and then here 2 pumps, and here 1 pump only. Okay. This constant pressure pump is very efficient, can save up to maximum of 80% of the energy. Okay, so here the willow provided for a shortcut in determining the capacity of the willow pumps, and here it is. It shows here the number of floors, and here the number of accommodation. Okay, like for example here, 3 lines above the bottom is accommodation. So say for example you have a 60 room hotel, 60, this one is 60 there, and it is a 11-story hotel, so there the model is there with an red ellipse or circle. Okay, just a duplication, and here the unit is 2 units of 2.5 kilowatts willow pumps. Okay, 2 units of 2.5 kilowatts willow pumps, like this one. And here is the controller indicator. Now you can also use this is a new topic, no? Deep well pump with solar pumps for energy efficient practice. Now we have to use also this hydro tester or pressure tester to determine if there are leaks in your system. So this could be used. And here is a meter center. You would see numerous meters installed here. Now this kind of installation, sometimes the problem is it has only have one valve in the line side of the meter. So the problem with this installation is that there is no valve after the meter. No? So there should be a valve after the meter, because if this is a high-rise project, a mid-rise or a high-rise project, when you do some servicing with the meters, when you remove it, water would flush through this location. So it is a messy thing. So usually we should provide another gate valve after the meter, so that before you do changes in your meters or remove a meter or replace it, you have to close your 2 valves first. Okay, and here is an installation where you would see a wrong installation of the check valve. See, this is the suction part of the pump, suction. So the check valve should be installed here on the discharge portion of the pipe, not in here, in the intake portion. Rainwater harvesting systems. We must now adopt rainwater harvesting, collecting, storing, processing rainwater for various consumption and use. Rainwater harvesting provides benefits such as water supply for both potable and non-potable uses, and it helps mitigate flooding and water supply shortages. Here are some slides that would suggest how you could collect rainwater. And this one would suggest how you could do some rainwater injection by providing for a filter tank here. So here is a filter tank. And of course, your well should also be lined with sand filters, just like this one, no? So that any dirt could be prevented from going to the aquifer. And here is a schematic of the Changi Airport in Singapore, where it makes use of rainwater for flushing the toilets in its restrooms. Okay, and it is a very elaborate way of collecting rainwater. And here is another way of collecting or cleaning the rainwater, filtering. And here are two local brands of rainwater filter, one from Water Care and another one from Emerald. Okay, water supply schemes for a certain village which we inspected recently. Okay, these were the schematics that we submitted to the owners, and here are the layout plans I just included here for your reference. And we also suggested converting the water from the creek in that village for water impounding, and therefore it can use to supply irrigation water to the open area of the subdivision. And then also the surface runoff from the gullies in the mountainous area of the subdivision could also be collected as to augment the scarce rainwater or scarce water in the area. Okay, so Aircon condensate collection. We should also provide for piping for condensates from the air conditioners. Otherwise, if you do not provide this, your condensate water will just be wetting the passageway, like in this picture on the left side. Greywater use. It is suggested that greywater should be used by modifying our system. The design of the septic tank already provided in the earlier slides already provide for possible use of the greywater. Here are schematics showing how you would be able to systematize, no? Make it systematic for the use of reusing sewage water. Okay, here's another one for rainwater collection. And here is my suggestion for rainwater collection. Rainwater must be collected and filtered. Rainwater to fill up the firewater tank, also to fill up the domestic water tank, and so on and so forth. And to illustrate it, here is my suggestion. There is a rainwater tank here, this one, and this is the firewater tank, and this is the domestic water tank. So you that is where your water from the from the water company would come in. And here your digestive, your septic tank, where you have the digestive chamber, settling tank 1, settling tank 2, and the sand filter, which I already explained, and a gray water tank here. So that's how we should be able to make your project sustainable by providing for sand filter, and a greywater tank adequate enough to hold off the greywater. The greywater would be used to flush the toilets and also for irrigation. And the rainwater could be used for to replenish this also, and for fire water. Okay, if provided with adequate filtering, it can also be used for domestic water purposes. It depends on the provision of the rainwater filter. Okay. Fireproof. So we are now on the last portion of our presentation. The Fire Code of 2008, Republic Act 9514, mandates that all buildings which are hotels, motels, dormitory, hospitals should have a sprinkler system, regardless of the height. Even if it is a one-story building, 2 or 3 or 4, even if it is less than 15 meters high, if it is a hotel, motel, dormitory, or a hospital, you have to provide for a sprinkler system. And also, if the building stores flammable materials, you should also provide for a sprinkler system, even if it is less than 15 meters in height. Okay? This is the provision in the code which mentions about that requirement. Fire Code 2008 RA 9514. All buildings, take note, all buildings shall be protected throughout by an approved supervised sprinkler system, except in buildings where all guest sleeping rooms and guest suites have a door opening directly outside the street or grade level, or exterior exit access arranged in accordance with so and so. So it mentions about this, that if guests are sleeping rooms, no, should be provided with sprinkler system, no exception. Okay, except that it is located on the ground and immediately to the road, opening to the road. Okay, so that's where the fire code is. Okay, most widely used is the sprinkler system. Okay, the fire pump, it consists of the fire pump, the jockey pump, fire pump controller, and the jockey pump controller. The jockey pump is a small pump about 1/10 of the size of the fire pump, which runs continuously to provide pressure in the hydraulic system. Okay, here I provide here a sample for the computation of the size of the fire water tank. So 11-story building, just follow this sample, and then the computation says 12,000 gallons requirement. And here is another example. This one is this one is for the fire water. Okay, computation for the fire water, while this one is the computation for the domestic water for the same 11-story building. In here, the computation only requires 9,680 gallons, while the computation for the fire water is higher, 12,000. So therefore, you have to adopt 12,000 for fire water and also 12,000 for the domestic water tank. You have to adopt whichever is higher between the domestic water tank, computed size of the domestic water tank, and the computed size of the fire water tank. Whichever is higher should be adopted. Okay, so these are just slides showing a previous project where yours truly inspected the design of a system, fire protection system, where the Siamese twin or the fire department connection is installed inside the lot. This is a big lot, something like several hectares in area, but the designer did not provide for a continuous piping of the fire water line to the street area where, where a fire truck could park and supply fire water to the building. So the designer thought that a driveway could be provided, but the truth of the matter is that after only 1 year after the construction of this building at the back of the lot, they constructed again a building at the front portion, thereby disallowing the entry of fire truck. So therefore, it is not practical. It is also unsafe. No. So that's why yours truly designed a piping of fire water line coming from the street here. This side is the street, and there is a fire department connection and a piping here to the different risers for this building and for this building. And sample hydraulic calculations. And here are just pictures of fire pumps. This upper left portion is a horizontal split case, the most popular, and in the middle is a vertical inline pipe, so it's space saving. And on the right side is a vertical turbine pipe, so this one is used for underground cistern, below floor cisterns, to make sure that there would be water at the suction side of the pump. Then here on the lower left portion is a engine-driven fire pump, usually being used in the factories or in the industrial sectors. Okay, and in selecting the fire pump, there is a need to just simply calculate the true friction loss calculation or pressure drop calculation. And when selecting, there's no need really to use ULFM type of pumps, no? As long as the capacity of the pumps is adequate based on the computed volume and pressure from the NFPA standard of calculating the pressure, or a software produce calculation, then there is no need for a ULFM type of fire pump. Okay, here I added here a schematic, a riser diagram showing a sprinkler system which doesn't have a jockey pump. So here you have here the fire water tank here, and you have here the fire pump, but you will notice there is no jockey pump. The pressure on the last sprinkler is being provided by this tank on the roof or on the elevated portion. This tank must have must be high enough to create a minimum of 7 psi pressure on the farthest sprinkler from this elevated tank. So usually this kind of installation using no jockey pump could be used for those building with sign or what you call this, advertisement at the top of the building. Okay, and here are samples of sprinkler nozzles. The sprinkler nozzles works at a minimum of 7 psi, so no need for don't believe that you need to have a very high pressure. No, the minimum pressure, calibration pressure of these sprinklers is 7 psi. But the minimum temperature is set 57 degrees. No? Some other type of sprinklers could actuate at a higher temperature, maybe 65 degrees or 70 degrees, and so on and so forth. And here is a facility showing an elevated water tank, and would create a pressure of 7 psi at the farthest point here. This type of system can be signed and sealed by a master plumber. No need for a professional mechanical engineer, because this one doesn't include a pump to provide the pressure of 7 psi and the farthest sprinkler. So we can sign this as master plumbers or plumbing engineers. And installation of sprinkler should be upright, not like in this picture. Should be like this, to make sure that no dirt particles would clog the nozzle. So if it is upright like this one, then chances are it is a lot better. Okay, and here is a slide that would make you easily check if the number of sprinklers installed in a project is compliant to the NFPA. This was taken from NFPA 13 table 8 -5 -.3.2 letter A. So say for example a 1-inch pipe, 2 sprinklers maximum are allowed. Then 1 1/4, 3 sprinklers. 1 1/2 pipe, 5 sprinklers. 2-inch pipe, 10 sprinklers. 2 1/2-inch pipe, 20 sprinklers. 3-inch pipe, 40 sprinklers, and so on and so forth. So if you are in construction management and you want to check if the installed fire protection system is compliant with the code, just count the number of sprinklers there and check the pipe size and see if it complies with these maximum number requirements. Okay, here is a fire hose cabinet. Usually the length of the hose is more than enough to reach the farthest point in a building. So if a building is very long, elongated, so you need to provide 2 or more of these, depending on the distance or the length of the building. And these are pictures of fire department connections or the Siamese twin. You would see this type and this type below, the yellow ones, and the one with red color are all single Siamese twin. But the picture on the lower right shows 2 Siamese twin, or 2 pairs of Siamese twin. So this one usually have 2 riser pipes, while these 3 have single riser pipes. Okay, and here is a sample of a hydraulic system for sprinklers. Here the sprinklers, the horizontal line, the vertical lines, the test line, and here the jockey pump. The jockey pump in the middle, and the fire pumps here. There are 2 fire pumps, and the fire water tank, which is divided into 2. You would also notice there is a drain pipe here, and there is this fire hose cabinets here, and the Siamese twin here, fire department connection. Okay, one lacking is the roof deck valve, a valve in the roof deck. If ever the building would be provided with a roof deck, you should also provide for a valve at the top of the building to be used by, let's say, a helicopter, in case there is this helicopter or watercopter. Okay, so upon calculating the volume of the fire water tank and also the domestic water tank, whichever of the 2 tanks have a greater volume will be adapted for the other one. And it would be good to adopt a rainwater tank, just like in my previous slides, so that our system would be sustainable. Okay, so that's the second to the last slide. My message: ang pagiging master plumber o plumbing professional ay simula lang para makarating sa mas malawak na profesyon, ang maging MEPF engineer, Okay, MEPF practitioner. Mahalaga ito sa buhay ng isang plumbing practitioner dahil ang profession na ito ay laging kaakibat ang mechanical, electrical, at fire protection practice. Hindi aandar ang water pump kung walang electrical. Hindi gagana ang bomba kung hindi dahil sa mechanical pump. Ang fire sprinkler system naman ay kailangan ng tubo para dumaloy ang tubig na pamatay sunog. Dapat ihanda ang sarili ng isang practitioner para dito sa combined practice na ito. Okay, so that's the last slide. And now, we're going to proceed to the chat. Okay. Here. Oh. We have here Mr. Richard Regulators again. Good evening, Sir Will. Oh, nice to see you again, Richard. Okay, it seems like the other guys are not here today. It's a Saturday. Maybe they are already off. Anyway, so I did not see any question from you, but anyway, later I will be posting this, and you can still post any question later. Okay, so let me check the time. Oh, the time spent is already almost 3 hours. 8:54. No. It's 2 hours. 2 hour and 24 minutes. Okay. So anyway, there was no problem, I think, with the internet tonight. So we are glad. Okay. So do you have any question, Richard? Okay, there is none. So now we're going to close our YouTube live, and let's have a short prayer again. In the name of the Father, Son, Holy Spirit, Amen. Thank you, Lord, for allowing us to conduct this YouTube live for this webinar on plumbing sanitary inspections. Thank you, and we hope that our fellow practitioners will be able to learn from this, and also share them also to others, to their projects, so that we'll be able to expand our knowledge. So Lord, thank you for always guiding us, for keeping us away from this sickness, from the COVID virus, and also for keeping us away from accidents. And also thank you, Lord, for blessing us with our family and friends. Again, we lift you this for the mighty name of your Son Jesus Christ.